In this video, we will explore the concept of conditional probability, which is a fundamental tool in AP statistics for understanding how the occurrence of one event affects the likelihood of another. By the end of this lesson, you will be able to calculate conditional probabilities and use the general multiplication rule to find the probability of two events occurring together. We begin with the notation. The expression shown on screen is read as the probability of A given B. This represents the probability that event A occurs under the assumption or condition that event B has already occurred. The formal definition is that the probability of A given B is equal to the probability of both A and B happening divided by the probability of the condition, which is event B. It is important to remember that the event we are given always goes in the denominator. Take a moment to think about why this is. When we are told that event B has happened, the entire world of possibilities shrinks down to just event B. We are then only interested in the part of A that lives inside that new, smaller world. To better understand this, let's look at a concrete example using a contingency table. Suppose we surveyed 100 students about their preferred superpower. Let's find the probability that a randomly selected student prefers flying, given that they are a freshman. First, notice our condition. We are given that the student is a freshman. This means we are only looking at the 40 freshmen in the top row. The rest of the table no longer matters for this calculation. Out of these 40 freshmen, how many prefer flying? We see that 25 do. We can simplify this fraction. 25 divided by 40 is 0.625. Now, let's use our formal formula to see if we get the same result. The formula says the probability of flying given freshman is the probability of being a freshman who flies, divided by the total probability of being a freshman. In our whole sample of 100, the probability of being a freshman who flies is 25 out of 100. The probability of being a freshman is 40 out of 100. Notice how the 100s cancel out, leaving us with 25 over 40, which is exactly what we found by looking at the row. Now that we understand how to calculate a conditional probability, we can rearrange that formula to find the probability of two events happening together. This is known as the general multiplication rule. The rule states that the probability of events A and B both occurring is equal to the probability of event A multiplied by the probability of B occurring, given that A has already happened. Mathematically, this is just our previous formula, with both sides multiplied by the denominator. Conceptually, it describes a sequence. First, event A must happen. Then, once we are in a world where A is true, event B must also happen. Note that the order doesn't strictly matter. We could also find the probability of B first, then multiply by the probability of A given B. Let's apply this to a real-world scenario. Imagine a jar contains 5 red marbles and 3 blue marbles. We are going to pull out 2 marbles one after the other, without putting the first one back. First, what is the probability that the first marble is red? Since there are 5 red marbles out of 8 total, it is 5/8. Now, assuming we successfully pulled a red marble first, how many marbles are left in the jar? There are now only 7 marbles total, and only 4 of them are red. So, the probability that the second marble is red, given the first was red, is 4/7. To find the probability that both are red, we multiply these together. 5 times 4 is 20, 8 times 7 is 56. This gives us 20 over 56. We can simplify 20 over 56 by dividing both by 4, which gives us 5/14, or approximately 0.357. This rule is general because it works even when events are dependent, meaning the outcome of the first event changes the chances of the second. Let's wrap up with one more example that combines these ideas in a slightly different way. This will help reinforce our first learning objective of calculating conditional probabilities. Consider this problem. In a town, 30% of people own a dog. 20% of people own both a dog and a cat. What is the probability that a dog owner also owns a cat? Notice the phrasing here. What is the probability that a dog owner also owns a cat? This is asking for a conditional probability because we are restricting our focus only to people who already own a dog. First, let's identify the events. Let event D be owning a dog and event C be owning a cat. Our goal is to find the probability of C given D. We are given 2 pieces of information. First, the probability of owning a dog, P of D, is 0.30. Second, the probability of owning both, P of C and D, is 0.20. Now we apply our conditional probability formula. The probability of C given D is the probability of both divided by the probability of the condition, which is D. Plugging in our numbers, we get 0.20 over 0.30. This simplifies to 2/3, which is approximately 0.667. This means that if you know someone owns a dog, there is a 66.7% chance they also own a cat. To summarize our goals, we have calculated P of A given B using the formula and tables and applied the general multiplication rule for dependent events. We have now covered how to define and calculate conditional probabilities and how to use the general multiplication rule. These tools are essential for analyzing complex probabilities in your AP Statistics course. Great job today!